Hello friends, Miss Paraso back again for part 3 of our review. Alright, we're going to see how much we can fit into this video here. So these last few questions, 12, 13, 14, are going to still stick with the Pythagorean theorem, but more specifically we're talking about the distance formula. Now you will have the formula available to you, but remember we talked about in class that it's really just the Pythagorean theorem squished into one step, okay? And these little subscripts here just means what's the distance between the 2 points, the x values. That's your left and right. That's that leg that goes left and right. And then this is the leg that goes up and down. We'll take a look at that in the graphs, okay? So if I'm trying to find the length of this line, aka the distance between those 2 points, I can go ahead and I can draw in, and let's do different colors here, okay? I can make it into a right triangle. And when I do that, I know that these are 90-degree angles because the x-axis and the y-axis, that's what they form. They are perpendicular to each other, right? So that allows me to just go ahead and count that distance. Well, essentially what I'm doing here is I'm taking that second point, the one that's furthest to the right, and I'm saying how far apart is it, just going left to right, how far, what's the distance here? I'm going from 1 to -4, right? So 1 minus a -4, well, that's 5, right? 1 minus 8, or we can just count it, right? Because we got the graph. So we can go 1, 2, 3, 4, 5. So that distance is 5. Okay, referring back to that formula there, the other leg of the triangle is simply saying, okay, what's the distance between here and here? Because like this is the level that this point is on. So I can say, okay, what's that vertical distance between them? And that means, okay, I'm at -1 and I'm up here to 4 again. So that's 1, 2, 3, 4, 5. So that's also 5. So there's the 2 legs of my triangle, and I'm trying to find out this length, just the diagonal length. So I'm going to use D for diagonal, but remember it's D squared. Okay, so now we go ahead. We got 25 plus 25 is equal to D squared. All right, we have 50 is equal to D squared. Take the square root of both sides, and it says leave it in square root form, so that's what we're going to do. Square root of 50 is equal to D. So the distance between those points is the square root of 50. Well, 49 is a perfect square, so it's about 7 point something units. Okay? All right, again, because we have the coordinate plane, it makes it so much easier just to count and use the Pythagorean theorem. All right, so we can go ahead and take a look that whenever it's asking for the distance, the shortest distance is always the diagonal. Okay? All right, so if we go here, we have 1, 2, 3. So that's 3 squared. All right, kind of switch my colors up here, but then the length of that side is 1, so we do plus 1 squared, and we're looking for this distance, that was a bad diagonal, all right, is equal to D squared. All right, well, 3 squared is 9, 1 squared is 1, so that's 10 altogether, and I'm just going to go ahead and take the square root of both sides. That is not a perfect square, so we're going to leave it since it said to leave it in square root form. Again, we can also throw on there that it's units long. Okay, for number 14, it's giving you the coordinates. So you have the option of using the distance formula, right? And so I'll show you that way, but I'll also show you like what we talked about in class where, okay, can't we just kind of do what we did with slope and say how far apart are these x values and kind of think of the number line in our head, right? But let's take a look at number 14 using the distance formula. First off, you want to go ahead and assign your points. So they always have an x and a y. This little subscript just means this is point 1, this is point 2. It does not matter which one is which, okay? So my distance is equal to the square root. I'm going to make a really long one so I can fit everything underneath. All right, my x2 value is -3, and I'm going to subtract my x1 value, which is 1, and I'm going to square it. All right, and then let's just change up colors here. I'm going to add that to All right, I got to go back and keep the order. Y2 is 5, and I'm going to subtract. What am I subtracting? I'm subtracting a negative 2, so I got to put that in there. Subtracting a negative 2 and then square it. Well, when I subtract a negative, remember that's really like adding. So we want to, that's where I have a little bit of issue is, and that's a common error for a lot of students, is that we're not paying attention. We just see 5 and I'm going to do 5 minus 2. That's the same as 5 minus a negative 2. It's not. We got to be careful. All right. So now we just do order of operations. So we're going to simplify the parentheses first. Negative 3 minus 1 is a negative 4. Keep those parentheses around it. And because we're going to end up squaring that number. And then 5 plus 2, aka 5 minus negative 2, is 7. I'm going to go ahead and just keep parentheses to let myself know that's the number I'm squaring. Okay? Now, I don't like doing horizontal, but I don't have enough space here. Okay, so let's simplify this further. Negative 4 squared is a positive 16. You will not get a negative. When you square a number, it's not possible to get a negative value. If the number's negative, a negative times negative is going to be positive. So just something to think about. All right? And then our final step is we do not take the square root of each one and then add them. No, that square root symbol is the same as a grouping symbol. So we have to add them together first. So 16 plus 49 is 65. And it wants us to estimate to the nearest tenth. I'm running out of room here, so you're just following my trail of arrows. Okay, and so, okay, we're going to estimate to the nearest tenth, so that means in my calculator, I'm going to go ahead and hit the square root of 65, and I get 8.0622 ... So it means it's approximately 8.1 units. All right, well, that wraps us up for the Pythagorean theorem. I'm actually going to cut the video here since the next part is all about angles. So come back, take a look at those things. I encourage you to go back and take a look at your angle relationships and the vocabulary, because remember, vocabulary is really big in helping us to define how we're going to set up our equations to find these missing values. All right, come on back for part, I don't know what part we're on, 4. All right, bye.